Greetings, everyone. So, today we're going to continue on our hip lecture, and I want to preference it by uh, just kind of talking about, as my major professor used to say, it is what it is. Human motion gets more difficult to analyze the closer you get to your center of mass. Um, in pitching, in softball, it's tough to hit a softball pitcher. And one of the reasons, there's a few reasons biomechanically, but one of the reasons is in baseball, we release out here, can't hide out over here, where our female athletes release closer to their midline, so it's harder to pick up, right? Same thing for human motion. Motions like ankle, subtalar, knee, wrist, elbow, those tend to be easier to decipher because they're kind of out on limb. But the closer you get to your center of mass, the more you get hidden by things like clothing and the trunk of the body itself falls as an illusion. One of the things I'm going to teach you guys is there's clues in the clothing. So in other words, if I have my arm out here and I do an illusion where it looks like my arm is abducting, but my shoulder joint didn't have any motion. Did you see motion in the clothing? No. But when I do abduct and move my shoulder around, you're going to see the clues that are in the clothing. Clothing is nothing more than a secondary superficial skin layer, if you think about it, right? Protecting us from the sun and protecting us from abrasion. Yeah, covering our stuff up. But it's like it's an external superficial skin layer. So just like when I move, my skin moves around with it. I can see my skin moving around. Same thing with the clothes. When we're going to move, we're going to see the clues in the clothing. Another thing I want to emphasize before we get into the hard in-depth principles of today's lecture is our joint motions are typically named after it looks like it's moving and it is. And typically it looks like it's moving and it is what we call open chain motions, where the distal segment is moving about the proximal segment. The distal segment is moving about the proximal. The distal segment is moving about the proximal. The distal segment is moving about the proximal. Sorry, I have a little femur here, and he almost fell off my lap. Where are you going, little guy? So for the hip, this is a right hip. How do I know? There's my patella, there's my foot, big toe, medial side, right hip. So all of our hip motions are named after it. Looks like it's moving, and it is. Abba, add-da-da-da. Right hip, abba, add-da-da-da-da-da. Abduction, adduction, abduction, adduction. Looks like it's moving, and it is. This is a kind of easy, it's easier to see frontal plane rotations with a front view, with an AP view. So what I'm going to do is I'm going to go to sagittal motions with a bilateral view, with a side view. Hip flexion, hip extension, hip flexion, hip extension. Hip flexion, hip extension. Now let's get into transverse and anatomical. Internal, external, internal, external, medial, lateral, medial, lateral. So a lot of times our initial movements are, it looks like it's moving and it is. That's why clockwise and counterclockwise, when you always hear lefty loosey, righty tighty, from the perspective of the smaller movable piece. Like if you think about a hose, you're opening up the valve for the hose. The house isn't going to move about that valve. The valve is going to rotate about the house. A smaller thing usually rotates about the bigger thing. And that's why all my friends when I was working on my doctorate and I had classes with engineers, my engineer friends hated biomechanics, our body, because as my engineers friends would say, when we design a house, that door, the smaller piece, is always going to move about the bigger piece, the house. So it's always going to have the same perspective. In biomechanics, yeah, it's nice and great when the smaller piece moves about the bigger piece. But as I'm going to show you today, the bigger piece can move about the smaller piece. I actually showed you that last lecture, but we're going to really get in depth and talk more about bigger piece moving about smaller piece. Okay, so that's important. The other thing from last lecture I want you guys to remember is the variation of ab and adduction in the transverse plane of the pelvis's or trunk's perspective. I'm going to get into the thorax's perspective when I do shoulder. But remember the analogy I gave about the interstate, where I-20 that runs up in Shreveport and I-10 both go east and west. But if you're on I-10, if you're in Lafayette, you cannot travel along I-20 unless you go up to meet it. You got to go up to get to I-20 and then have east and west. So in anatomical position, our options are flexion, extension, ab, adduction, internal, external rotation. That look like this: flexion, extension, ab, adduction, internal, external rotation. For me to have horizontal abduction or adduction, I got to move up. I got to move. I have to flex to then get on Interstate 20, and now I can have a variation of regular ab and adduction. Horizontal adduction, horizontal abduction. And it reminds me of a saying, you know, when you're young and I was kind of goofy and I'd try to say silly things and be a smart aleck. And my mom would say, you know, 2 wrongs don't make a right. And I'd say, yeah, but Mom, 3 lefts make a right. I'd get in trouble. But the concept is, if you think about it, if you're here on a road and you take, let's say, this is a left and this is a right. If I take 1 right, I end up here at the next stop sign. But if I take 3 lefts, a left, and a left, I end up getting to the same place. 3 lefts make a right, technically. So let's go through the realm of shoulder motion. Well, hip and shoulder are going to have the same motion, so I can do a shoulder analogy to explain a hip concept. Nothing wrong with that. Regular abduction. Horizontal adduction brings me back to 6 o'clock. I went away from 6. And now I have 2 different ways I can go back to 6. I can go back the same road I traveled, or I could go back through this new interstate. And then how do I get back? Extension. Horizontal extension gets me to the same place. Flexion, horizontal gets me to the same place. Okay? So it's a version. You can't do horizontal AB and adduction in anatomical position. You're not up there to travel on that road. But it still holds true to the same 3 planes of motion. When I'm in anatomical, my options of rotation are ad in the frontal, flexion, extension, sagittal, internal, external rotation, transverse. Well, when I go up to get on Interstate 20, I can't flex and extend here. So I still have 3 options of motion. I could either go ad or more ab. I can internally or externally rotate, but that's in the sagittal globally. So I have frontal, I have sagittal, and now my transverse is now horizontal AB and adduction in the room's perspective. So it doesn't avoid any of those rules, okay? The reason we need to talk about the socket here is of importance. And before I get into the why, let's talk about what we've never had before. For the knee joint, we had femur, singular, and we had tibia, singular. Here we had talus, and we had tibia and fibula, but talus moves about the tib-fib, or the tib-fib move about the talus. The tib-fib make up the socket itself, okay? When we look at the pelvis, when we look at the socket of the pelvis, man, we've got some really interesting stuff that doesn't happen anywhere else in the body. One, we have, again, 3 bones that fuse into this socket, but also the trunk, our lumbar vertebra, articulate with our sacrum We call that the sacroiliac joint. So we have our lumbar, and our lumbar, the movable parts, eventually become unmovable parts. You have some fused sacral bones here, bedrock. And there's an articulation between the ilium and the sacrum, and they call that the sacroiliac joint. There's a little bit of play, slight play, amphiarthrotic because of ligaments, slight, not a lot, slight. But for the most part, wherever this goes, this goes. This is like a block, okay? If I abduct here, the other side's going to go along for the ride because they're connected. They're connected through the fused sacral bones. If I spin, both sides got to go. If I go forward and back, both sides got to go. So that's unique. When I rotate my right ankle, my left ankle doesn't have to go. When I rotate my right knee, my left knee doesn't have to go. And that could be open or closed. That could be when my feet are on the ground or not on the ground. I could do a one-legged squat and my left knee doesn't have to do anything. I could just have it in anatomical position. But the hip, if I move the right femur, my left doesn't have to do anything. But if I move the right socket, the other side has to go somewhere. That's unique. That's different. Okay? So the pelvis, we talk about the pelvis. What is the pelvis? The pelvis is all of this stuff. The pelvic girdle, all of the different articulations that make up this bedrock. And why do we need bedrock? Because last time I checked, if you're going to build a skyscraper, you better have it on a solid foundation, anchoring the skyscraper, okay? So the pelvis has its own unique perspective of motion. In fact, some could say the pelvis is never lost. There's a thing in The Lord of the Rings, and Gandalf says, a wizard is never lost. No, a wizard is never late. He is always on time, and he's always right because he runs on wizard time. The pelvis is never lost. The pelvis is always looking forward. If you think about how we have eyes, but it's kind of tricky. Our sockets are always looking forward, but I could actually make my eye look anywhere I want. Crazy. So by the way, the eyes are actually a part of your brain. That's weird, but it's so cool. The pelvis has a perspective. It has eyes. And you can think about those eyes as always kind of facing forward. And the pelvis will always face forward if it's never lost. So the pelvis is going to have planes and axes. It's going to have it's going to have sagittal plane rotation. It's going to have frontal plane rotation, and it's going to have transverse plane rotation. The pelvis is going to have a perspective. Think of it, I kind of drew this very awful pelvis, but so what's missing? What's missing is the sacrum, your tailbone, your trunk, but this is the right and left, what they call hemipelvis each side. But again, I can't move the right independent from the left. Its upper extremity cousin, the scapula, the shoulder girdle, I could move the right one, move the left one. I could do like an NSYNC dance. You're tearing up my heart. You can't do that here. The right side of the pelvis can't go up and down, front, back, open up. They are attached through that pubis and through the SI joint, the sacroiliac joint. So the point is, if you think about, if you expand this pelvis to look at like a baseball or a basketball, the pelvis can rotate in all three planes about all three axes. It can have anterior and posterior rotations about a bilateral axis, and our hip joints serve as that bilateral axis. It can have right and left transverse plane about a polar axis, and it can have right and left lateral rotation about an AP axis. So frontal plane spin, transverse plane spin, sagittal plane spin. Why is this important? It's very important because, let me see if I could find this photo, because this is going to help us explain the kind of movement strategies that we do to keep our eyes level, to keep our shoulders level. You know, in building, you have levels, right? You have levels that you put on things to make sure things are balanced and across. Well, we have levels. It's easier for you to work when your shoulders are level than if you're at an angle. And it's easier for you to process information if your eyes are level than if you're at an angle. If I'm trying to process data like this, I'm going to get confused and fall down. You have mechanisms in place where you want to keep your eyes level because that's how you're used to seeing the world. And that's how you could process information. So we have to have mechanisms in place. I'm going to give you this simple example. If my body leans to the right, I need to be able to lean my neck to the left to keep my eyes level. Same thing happens with our lower extremity. So check this out. I posted this on my Facebook. Kind of got a few laughs from my former students. But notice how if I have, let me make sure I get the correct hip, right hip. So if my right hip is abducted, the whole pelvis is going along for a ride. Because I can't just move the right socket. The left socket's going to go up in this case. So the pelvis has a perspective of rotation. Think of it as the pelvis is doing a cartwheel. Pelvis is doing a side cartwheel. Now the issue is, well, if I abduct on my right hip and everything's now tilting over to my right, what are the things that I have in place to keep my shoulders level or my eyes level while I'm trying to get work done or while I'm trying to catch a pass or while I'm trying to be athletic? Do things. Your trunk, as you're going to see here, is going to bend back the other way in order to keep your shoulders level. So the point is that we have a lot of connections, and this is going to be the last part of your test, and I'm going to teach you till I can't teach you any better. I'm going to do the best job I can, but we have to look at all the things that play a role in these functional tasks. Hip motion, pelvic girdle rotation, and trunk motion, all coming together to help keeping you to do things that you need to do functionally. Hip motion, pelvic girdle rotations, and trunk motion. They all play a role in you being able to walk, jump, move, reposition, okay? So the pelvis has a perspective. What's really cool is the pelvis's perspective, I think, is pretty simple. There's no flexions and extensions and abductions, and it's because it's more pure. Think about it. If the pelvis is kind of more represented by this baseball, when the baseball spins, it's spinning about its center of mass. It's more pure rotation, right? Flexion, extension, abduction, that's general motion. Yeah, there's some rotation to it, but there's also some linear, get it up in the air, bring it down from the air. When the pelvis spins, it's more pure. It's more about the center of mass of the pelvis. Where's the pelvis' center of mass? Somewhere in here. So when it rotates in the frontal plane, that's a frontal plane rotation. When it's rotating the transverse plane, it's a transverse plane rotation. Sagittal plane rotation. So the point is, when the pelvis spins, we're going to have an R word next to it, just like we do for the hip. Hip external and internal rotation because it's more pure rotation. So we're going to have pelvic girdle rotations. And it's not disrespecting hip motion. You may still have hip motion. But it's what is the pelvis doing? This is what I mean by that. If the left hip moves by itself, left hip add, flexion, extension, the pelvis doesn't have to go anywhere. But once the socket moves about the ball, the whole thing has to go somewhere. All of a sudden, the right side has to do what the left side is doing. So it has a unique perspective when the pelvis moves about the femur, when the socket moves about the femur. It's like when you have a little brother, cousin, or little brother, sister, and you go on a date and the little brother, sister has to tag along because mom and dad say so. They got to go along for the ride. Here, doesn't have to go along for the ride. But when I do this, the other side has to go along with it. okay? In addition, pelvic girdle rotations help us communicate motion a lot easier, as we're going to see down the road. In other words, for you future therapists and chiropractors and orthos, you're going to see people's pelvic positions. Remember how I taught you about position? Where are you at relative to anatomical? And you're going to be able to make some observations like someone has anterior tilt. Someone has posterior tilt. Someone has lateral tilt, right lateral tilt, left. Their pelvis isn't where it needs to be relative to anatomical. And I'm going to show you how when the pelvis is tilted in the front, that must mean the trunk has to be having some abnormal position relative to anatomical. And the hips have to have some abnormal position relative to anatomical, because it's all connected, okay? The best way to look at pelvic girdle rotations when your feet are on the ground is, if I had a basketball, I don't, I'm going to try to have one for next class, but you can imagine this. The basketball has perspective of spin. I can spin the basketball forward, give it front spin, and when it hits the ground, it's going to roll forward. I can give the basketball backspin. And when I spin it like this and it hits the ground, it's going to roll backwards. Another word for forwards is anterior. Another word for backwards is posterior. I can give the basketball side spin. And, well, Campbell, you could do two side spins. Yeah, but if I give it side spin like this and it hits the ground, it's going to roll to my right. Right side spin, right lateral, side to side, right lateral spin. And if I spin the basketball like this and I drop it, it's going to roll to my left. Left lateral spin, left side spin. And then we have the transverse spin that I could do with a basketball. That's practical if you're going to spin the basketball. Maybe that's why I didn't bring the basketball, because I didn't want y'all to see how bad I am trying to spin it on my finger. But if I give it transverse spin, I could spin it around my finger. Transverse, super easy. Right lateral. Hey, right, spin laterally, spin externally, internally. But for the pelvis, you only have one of it. You have a right and a left side, but they're all doing the same thing. So the pelvis, you could kind of think of it as your head. Look to your right, how are you going to spin? Look to your left, how are you going to spin? Right transverse, left transverse, right transverse, left transverse. Hey, pelvis, look to the right. Okay, right transverse, pelvic girdle rotation. Hey, pelvis, look to your left. Sure, left transverse, pelvic girdle rotation. So these aren't real tough. It's going to be tough to get down the verbiage. That's why you practice, and it's going to be tough to understand. Tough to understand. If I do my job right, it's going to be easy to understand. Okay? I hope y'all aren't hearing those dumb notification sounds. The basketball can spin. Yes, but the basketball cannot spin itself. The baseball can spin. Yes, but this baseball cannot spin itself. I have to give it the spin. Same thing with your pelvis. Can the pelvis rotate? Absolutely, but it cannot rotate itself. Well, what rotates the pelvis? Traditional joint motions. Hip motions rotate the pelvis. I'm going to teach you later, not right now, how trunk motions can rotate the pelvis if you're off the ground. I'm going to teach you that down the road. So this is why this is important. The pelvic girdle can rotate, yes, but it cannot rotate without joint motions. Dr. Campbell, how do I know when to ask which? I'm going to ask you. From A to B, what was the motion of the hip? Hip flexion, extension, abduction, adduction, internal, external rotation, horizontal, abduction, all that stuff. Did the pelvis rotate? If the answer is no, you're done. If the answer is yes, you just follow that up with how did it rotate? And remember, the pelvis is always right. The pelvis is always correct. The pelvis is never lost. So the pelvis has a perspective of sagittal, frontal, and transverse, regardless of if the pelvis is here or if regardless of the pelvis is here. Let's say you pivot it around your right hip, you flex on your right hip, maybe I drop the baseball and I'm going to pick it up. The pelvis is always looking forward. So if I'm pivoting about my right leg to pick up a baseball, this is the pelvis's frontal, this is the pelvis transverse because it's relative to the pelvis. Okay? All right? So now I get to show you some examples of, did the pelvis rotate? If the answer is yes, how? If it rotated, something had to rotate it. So there had to be some joint motion happening there. What are those? Like shoes, right? What are those? I'm like 2 years behind all of my dad jokes, so sorry. So I'm hoping that I laid down the foundation. I'm about to do a lot of practice with you guys. A lot of practice. But if you didn't quite understand the foundation, go back and rewatch the first 20 minutes or so of this video, okay? This is important because when we start to get into midline type motions, man, we're going to need a lot of clues. And I'm going to use things like a level. Remember how I said you got to want to keep your eyes level, shoulders level to work? I'm going to put a level across my pelvis. Because again, what's cool is in normally functioning humans, you could kind of take a level right here. You know, my right isn't going to, right? This is going to relatively be level. And if I have changes of this globally, well, then I'm not level. My left is higher than my right, but that's because I'm tilted. I got to correct that tilt. I'm anteriorly tilted. I got to correct that. Okay? All right. So let me give you guys some practice. And if you're playing along from home and everything's fine, awesome. If you need some extra work or you're not quite sure, hit me up, okay? Hit me up. All right. All of these are going to be pelvic girdle rotations because of hip joint motions. So as theoretical kinesiologists, as detectives of human motion and position, we're going to just need to ask ourselves some simple logical questions. Did the pelvic girdle rotate? That's yes or no. If the answer is no, we move on. If the answer is yes, you got to follow up with how did it rotate? Was it a frontal plane, a sagittal plane, or a transverse plane? Obviously, in most stuff, we're going to have a combination. But for this test, I'm going to stick to the basics. Once you identify sagittal, frontal, or transverse, then all you got to be is, okay, great. Did it go clockwise or counterclockwise in the frontal? Did it go clockwise or counterclockwise in the sagittal? Did it go clockwise or counterclockwise in the transverse? And you get your pelvic girdle rotations. And then you say, okay, that's great. The basketball spun, the baseball spun. What spun it? That's what's great about this concept. The pelvis can only spin in 3 different planes. But what spun it could be right hip only, left hip only, both hips, and as I'm going to show you eventually, just the trunk if my feet are off the ground. So a lot of things could be the reason that it spun. Let me give you an example. I could spin the ball with just my left hand if I'm trying to spin it on my finger. I could spin the ball with just my right hand, or I could spin it with both. I could spin the basketball and the sagittal with both. Or if my hands are big enough and I could palm it, I could spin it with just my left, or I could spin it with just my right. The spin is going to be the same for the whole ball, but what spun it could be different. That's what we're about to practice right here, okay? All right. Let's do this. I'm going to first start off with my skeleton helping me show you what's up, and then we'll proceed with no skeleton so that you guys can visualize the skeleton inside. Okay, we're going to make it work. Here we go. On 2. Ready? Break. All right, testing. 1, 2, 3. All right. Start here. Start here, and I do this. Did the pelvis rotate? Yes. How did it rotate? Well, if the pelvis was a ball, if the pelvis pelvis was a ball and I gave it the same type of spin and I let the ball roll, how would it roll? It would roll to my right. Right lateral. It would roll to my right side. Right lateral pelvic girdle rotation. Now coming back would be the opposite spin. Left lateral pelvic girdle rotation. Right lateral pelvic girdle rotation. Left lateral pelvic girdle rotation. Now, you may say, well, what about the hip stuff? Well, the hip motion is what caused the right or left lateral pelvic girdle rotation. My right lateral pelvic girdle rotation happened because I had right hip abduction. And the left lateral pelvic girdle rotation occurred because I had right hip adduction. And I could continue to have more left lateral if I get my left foot off the ground because it's kind of acting like a kickstand, and I do this. Ooh, need to work on my balance. If I do this, that's more left lateral because of more right hip adduction. Right lateral pelvic girdle rotation because of right hip ab. More right lateral pelvic girdle rotation because of more right hip ab. Left lateral pelvic girdle rotation because of right hip ad. Okay? One of the best ways, or one of the ways you can look at pelvic girdle rotations, again, is spin. I use that here. Right lateral, ball's going to roll to my right side. Left lateral, ball's going to roll to my left side. Another way you can look at pelvic girdle rotations is like a cup. You imagine like a cup filled with water, or a bucket. And the pelvis is kind of like a chalice. You could just imagine like these ilium kind of serving as the rims of the glass or the bucket. And if you have right lateral pelvic girdle rotation, you're going to start pouring water out the right side from anatomical position. Right lateral, water pours out the right. Left lateral, water pours out the left. Now, how would you stop water from pouring out the left side? Have right lateral to bring you back to anatomical. How do you stop water pouring out the right side? Left lateral brings you back to anatomical. Pouring water out the left, right lateral bring you home. Pouring water out the right, left lateral bring you home. So let's look at that again from maybe how we're pouring water out of a cup or a bucket, okay? Right lateral pelvic girdle rotation, pouring water out the right side of my pelvis. Because of what? Because of my right hip abduction. Left lateral pelvic girdle rotation brings me home because of my right hip adduction. Okay, let's do the other side. Left lateral pelvic girdle rotation, left-sided spin, or pouring water out the left side because of left hip abduction. Right lateral pelvic girdle rotation brings me back home because of left hip adduction. Let's think about, I'm trying to be practical here, but think about how many different ways people walk. Some people walking like this. There's nothing wrong with that. But that's pelvic girdle rotations, man. Watch. If I had a, let's see if I tried to have a level. Okay? Right lateral, left lateral, right lateral, left lateral. And again, the illusion is because the trunk, as I have right lateral, the trunk is going to bend back the other way to keep my shoulders level and my eyes level. But if my trunk didn't bend the other way, you'd see this, and then this, and then this. Okay? Somebody's walking with a lot of hip flare. That's pelvic girdle rotations and hip motion. Boom! Right lateral pelvic girdle rotation because of left hip adduction. Boom! Left lateral pelvic girdle rotation because of right hip adduction. Right lateral to bring me back up, and then left lateral to take me away. Okay? happens if I have both feet on the ground? Sticking to our lateral example, okay? No problem. If I have both feet on the ground and I have right lateral pelvic girdle rotation, pelvis went from not leaking water to leaking water out the right side. And where this gets confusing is someone may say, well, how in the world did you have right lateral when the center of mass of your pelvis shifted to the left? And I say that's really easy. I could take a basketball and give it right lateral spin and actually throw it to my left, but once that ball starts spinning on the ground, it's going to start rolling that way. We do not use linear concepts to explain rotational concepts. Two different worlds, linear and rotation. This is all about the spin. It's all about the spin. So some students will miss because I have this. When I have both feet on the ground, I have this, and they say, oh, the center of mass went to the left. Big deal. The rotation went to the right. If you use your water pour analogy, here to here, I'm pouring out water on the right side. Right lateral pelvic girdle rotation. That's the pelvic girdle rotation. What caused it? What was responsible for it? What joint motions happened to make the pelvis spin to the right? Well, in this case, I had, remember, the pelvis is always right. The pelvis is always home. The pelvis is never lost. So when I do this, I'm showing you where my hips would have been if they stayed in anatomical, from the pelvis's perspective, from the socket's perspective. What is the new position of my hips? They went from anatomical to my left hip being adducted and my right hip being abducted. Right lateral pelvic girdle rotation because of left hip add and right hip ab. Left lateral pelvic girdle rotation because of left hip ab and right hip add. You may be asking yourself, well, if the hips are doing two different motions, how is that possible for the pelvis to be doing, because the pelvis is one thing? You know this. You've been doing this your whole life when you were a kid and you were on a merry-go-round, and you think about being on a merry-go-round and you asking your friends to spin it, or the adults, or if you had the park, your brother, sister, cousin. The best way to rotate a merry-go-round, if we're looking at it now from over the top, is to have one person push the merry-go-round this way, to my left, and someone on the other side of the merry-go-round to push it the other way, to my right. Because both of them are going to be producing the same rotational force. Two different linear forces, but the same rotational force. That's what's happening at the hips. You have two different linear forces, two different joint motions from the hips perspective, but the same rotational force from the pelvis's perspective. That's awesome. Okay? So, right lateral pelvic girdle rotation because of right hip abduction, left hip adduction. Left lateral bring me back home because of right hip adduction and left hip abduction. If I keep going, more left lateral pelvic girdle rotation because of more left hip ab and right hip add. Again, I could do it because of one hip. I can have left lateral because of left hip ab, right lateral because of left hip add. I could do it on my right side. Right lateral because of right hip ab, left lateral because of right hip add. Okay? That is frontal plane pelvic girdle rotations. Very important for gait, very important for walking, very important to see how that pelvis goes laterally when you're walking. When you weight bear on your right and you have to swing your leg through, you don't want to trip and hit it on the ground, right? So what do? We hike. This is a function of a first-class lever. We want to get this left side up so that we have room to swing through. So So the easiest way to get this left side up is to hike this right side down. Right lateral pelvic girdle rotation is going to bring my right side down, but it's going to bring my left side up. So I can swing my leg through. And then I'm going to have the exact opposite. Now this side up is this side's down. So I need to hike my right side up so I can swing my leg through. Hips and pelvis, okay? The next one we're going to talk about is sagittal plane pelvic girdle rotations. You can use the ball analogy. Anterior spin is going to make the ball roll forward. Posterior spin is going to make the ball want to roll backwards. If you like the cup analogy, the water analogy, even easier. Anterior spin is going to pour water forward. Posterior spin is going to pour water backwards. What's going to stop water from pouring out forwards? Posterior spin. So if you're anteriorly tilted, anteriorly rotated, posterior pelvic girdle rotation is going to bring you home. What's going to stop you from pouring water out the back? If you're posteriorly tilted or posteriorly rotated, anterior spin is going to stop you. So these are sagittal plane pelvic girdle rotations. What are sagittal plane hip motions that are going to be responsible for it? Flexions and extensions in anatomical, okay? So the motions of the pelvis is going to be anterior, posterior. The reason they occur is because of the hip motions, flexion, extension. Let's see what that looks like. Anterior pelvic girdle rotation. Anterior pelvic girdle rotation because of right hip flexion. Posterior pelvic girdle rotation because of right hip extension. More posterior pelvic girdle rotation because of more right hip extension. Anterior pelvic girdle rotation because of the right hip flexion. Does it have to be right hip? Of course not. It could be the left hip. Anterior pelvic because of left hip flexion. Posterior pelvic because of left hip extension. More posterior pelvic because of left hip extension. Can it be because of both? Absolutely. Anterior pelvic girdle rotation because of bilateral hip flexion. Posterior pelvic girdle rotation because of bilateral hip extension. Now again, I am showing you the trunk going along for the ride. Guys, a lot of times the illusions on these are very subtle. When the trunk cancels out, you're going to see some posterior tilt, some anterior tilt, posterior pelvic girdle rotation, anterior pelvic girdle rotation, and you better be able to see what's happening here. It's not always going to be obvious. A lot of the time it's going to be subtle. But the reason that I'm going to teach you to be able to see this cancel out, you're like, well, why is the trunk going along for the ride sometimes and not for the other? Is because we can cancel out some of the stuff with trunk motion. And I'm going to explain that to you in a subsequent lecture. When I flex my trunk at the same time as I posterior pelvic girdle rotate, it brings me from anatomical to a flexed position in my trunk. And when I extend my trunk, when I'm in an anterior tilt, it brings me from anatomical position to an extended position. Okay? So, anterior and posterior pelvic girdle rotations. In anatomical, they're going to be because of hip flexion and hip extension. Okay? If I rotate, if I pivot to pick something up off of the ground, I'm going to have anterior pelvic girdle rotation because of my right hip flexion. My left hip, once it's off the ground, it has nothing to do with the rotation of my pelvis. Look, if my left leg is off the ground, all I can do is have hip motion. My pelvis isn't going anywhere until my right hip makes it go places. And that is because you can't move yourself unless there's something fixed efficiently. You got to have something anchored to hold on to, a fixed part so that you could move other parts. So when my right leg was on the ground, my right leg was interlocked with the ground, a friction that I was getting from the ground. So basically it looked like this. If my left hip was off the ground and I said, hey, left hip move, my left hip is like, ooh, I'm free to go anywhere. My right hip was on the ground. My right hip was anchored, was fixed. So therefore, because my right leg was fixed, then my pelvis stuff could orbit and move about it. Okay, that's important. To have efficient pelvic girdle rotations, I'm going to have something that's anchored, fixed to the ground to be able to have the pelvic girdle rotation. So that's important, that if my left leg is off the ground, none of my left hip stuff is going to be responsible for the pelvic girdle rotation. It's only the part that's going to be anchored on the ground. Okay. Next lecture, I'm going to go into transverse. This lecture, it's important that you guys understand the frontal rotations of the pelvis and the sagittal rotations of the pelvis. Right lateral, left lateral, anterior, posterior. And once we have pelvic girdle rotations, then we could say, okay, great. What were the joint motions that made that happen? Right hip, left hip, or both hips, depending on what's on the ground and depending on what I use. Okay? If you guys have any questions, let me know. Whew, I'm starting to lose my voice. I'm trying to give you everything I have, and help me help you guys. Watch this as many times as you want, and feel free to hit me up for clarification. Okay? Hope all's well.